Today's lesson is on Poisson distribution. What is a Poisson distribution? The Poisson distribution is a discrete probability distribution which expresses the probability of the number of events occurring in the fixed period of time or space. Hence, Poisson distribution is a special discrete probability distribution. Okay, it expresses the probability of the number of events occurring in a fixed period of time or space. Example, we have number of accidents on a highway in a day. So what is the event here? Accident. So what is the period of time? 1 day. Next example, we have the number of typing mistakes on a page. So what is the event here? The typing mistakes. So what is the fixed space here? On a page. Let's look at the Poisson probability distribution. Okay, first, if we have a discrete random variable x that follows a Poisson distribution, so it is written as x. Okay, the symbol here, P0, that represent Poisson, and in the bracket we have the symbol lambda. So lambda is the mean number of occurrences in a given time interval or space. Thus, the probability distribution of the Poisson random variable x is given as the probability for the little x to occur is e to the power of negative lambda times lambda to the power of x divided by x factorial for x 0, 1, 2 onwards. So remember, your lambda means the mean number of times an event to occur, and e, the Euler number, takes the value 2.71828. Let's look at the example. The number of customers arriving at a service counter of a shopping center follows a Poisson distribution with a mean of 0.6 per minute. So calculate the probability of no customers arriving at the counter in a period of 1 minute. At least 2 customers arriving at the counter in a period of 1 minute. Less than 2 customers arriving at the counter in a period of 10 minutes. Okay. We have number of customers arriving at a service counter with a mean of 0.6 per minute. Okay, the mean lambda is 0.6 for every 1 minute. Okay, so you need to calculate no customer in a period of 1 minute, at least 2 customers in a period of 1 minute, less than 2 customers in a period of 10 minutes. Firstly, you need to define your random variable x. So x will be the number of customers arriving at the counter. So write this in mathematical symbol. So x has a Poisson distribution with a mean of 0.6 in a period of 1 minute. Recall the formula. For the probability distribution of Poisson, it is e to the power of negative lambda times lambda to the power of x divided by x factorial. So for the first question, no customers arriving at the counter in a period of 1 minute. So your X must be 0, no customer. So just substitute X as 0 and lambda as 0.6. Okay, you have 0.5488. Now, we can work smart. 0 factorial is 1. 0.6 to the power of 0 is 1. So all you need to do is just to calculate e to the power of negative 0.6. Okay, now let's look at the second question. At least 2 customers arriving at the counter in a period of 1 minute. So, how do we write? P of X must be greater equal to, because the question says at least 2 customers arriving. Now, your X takes the value from 0, 1, 2 onwards. So we do not know where it ends. So we have to use this method in order to find Px greater equal to 1 minus Px less than 2. So what is Px less than 2? Px equals 0 plus Px equal 1. Okay, again you substitute your X as 0. Lambda is 0.6. Okay, here Px equal 1 means, okay, you substitute X as 1. Okay, your lambda remain the same, 0.6. Okay, you must be careful when you want to evaluate using the calculator. Make sure you press the calculator correctly. So we have 0.1219 rounded off to 4 significant figures. Okay, I forgot to mention earlier, Poisson property has one unique characteristic. It only has one parameter, which is the mean lambda. Okay. Part C, you are required to find the probability of less than 2 customers arriving at the counter in a period of 10 minutes. Now, your questions states that the number of customers arriving has a mean of 0.6 every 1 minute. So, what must you do? Okay, you must find the mean of the number of customers arriving for every 10 minutes. So you have to multiply 0.6 with 10. So you have X has a Poisson distribution with lambda 6 in a period of 10 minutes. So it's important that you state the interval. So the probability of X less than 2 is Px equals 0 plus Px equal 1. So substitute the values of x0 into the formula and substitute x equal 1 as in the formula with lambda 6. Okay, the mean is 6 in a period of 10 minutes. So calculate carefully. You have 0.01735. You round off to 4 significant figure. Next, we look at how to find the mean and variance of the Poisson distribution. Okay, your X is discrete that follows the Poisson distribution with mean lambda. Then the mean of the discrete random variable X is just lambda. The variance of X is also lambda. Hence, the standard deviation will be square root lambda. So that's one thing unique about the Poisson distribution. It has the same value for mean and variance. An example on how to find the mean and variance of a Poisson distribution. Okay, here the number of times an amplifier breaks down in a year follows a Poisson distribution with a mean of 3. So here your lambda is 3 and your time interval is 1 year. If x represents the number of times an amplifier breaks down, so find the mean of x and variance of x. Find the probability that the amplifier breaks down twice in 2 years. Find the probability that the amplifier functions well for 1 week without any breakdown, assuming that there are 52 weeks in a year. Now, part A is very straightforward, just finding the mean and variance. Part B, the amplifier breaks down twice in 2 years. So now your time interval has increased to 2 years. Part C, the amplifier functions well. So this is the opposite from the question. The question gives you an amplifier breaks down. So how are you going to solve this? And the interval is for 1 and the time interval is 1 week. And we have to assume that there are 52 weeks in a year. So the solution for part A, the mean of x is lambda. So lambda is 3 and the variance of x is lambda. So the lambda is 3. Hence you have the mean of x as 3 and the variance of x as 3. Now you need to calculate the probability that an amplifier breaks down twice in 2 years. So what is your mean for the amplifier to break down in 2 years? So the mean will be 6 in 2 years because we have the mean is 3 in a year. So the mean will be 6 in 2 years. Just multiply 3 with 2. Okay. Now we need to find the probability that it breaks down twice. So Px is 2 because x is given as the number of times an amplifier breaks down. So since the amplifier breaks down twice, so we have Px equal to, so substitute your lambda as 6 and your x as 2. Evaluating, you have 0.04462 rounded off to for significant figure. For part C, your time interval has changed to 1 week. So we have 52 weeks in a year. So what is the mean number of times an amplifier breakdown? So we just multiply 3 with 1 over 52. So the mean will be 3 over 52 in 1 week. Remember, this is the mean for the number of times an amplifier breaks down. So your question says that the amplifier functions well for 1 week. So when the amplifier functions well without any breakdown, so your x must be 0. There is no breakdown. So substitute your x as 0. Okay. And the mean number of occurrence is 3 over 52. So you calculate, you have 0.9439 rounded off to for significant figure. Another example, question 3 in exercise 3.11. Here you have the number of telephone calls received at a telegraph office in a time interval of 5 minutes follow a Poisson distribution with mean 0.4. Find the probability that no telephone calls are received between 1145 hours and 1150 hours. Find the probability that more than 3 telephone calls are received in a time interval of 25 minutes. So first, you have to define your random variable x. So your random variable x is number of telephone calls. And you have to describe the distribution of x. So x follows the Poisson distribution with mean 0.4 in a period of 5 minutes. Now, no telephone calls received. So your x is 0. Between 1145 hours and 1150 hours, how many minutes are there? Yes, 5 minutes. So you can straight away use lambda 0.4 and then substitute x0 into the formula. So you have 0.6703. Okay, the probability that there will be no calls between 1145 hours and 1150 hours is 0.6703. Part B, you are required to find the probability that more than 3 calls received in a time interval of 25 minutes. Now, your question states that the mean is 0.4 in a time interval of 5 minutes. So what is the mean in the time interval of 25 minutes? So the mean will be 0.4 times 25 over 5. So you have x follows the Poisson distribution with mean 2 in a period of 25 minutes. So remember class, your lambda depends in the time interval. Okay, your lambda depends in the time interval. So for the question, you need to find more than 3 calls received. So Px is greater than 3. And as I mentioned earlier, your x takes the value of 0, 1, 2, 3 onwards. So it's continuous and it's never ending. So you have to find 1 minus px less than equal 3. So px less than equal 3 is px equals 0 plus px equal 1 plus px equal 2 plus px equal 3. So substituting the values of x, okay, when x is 0, when x is 0, when x is 1, when x is 2, when x is 3. Notice that I take out my common factor, which is e to the power of negative 2. It will be easier for you to calculate. So evaluating, you have 1 minus 0.8571, which will give you the value of 0.1429. You round off to for significant figure. Now we look at question 4. Number of accidents occurring in a factory each week follows a Poisson distribution with variance 2.8. So find the probability that no accidents occur in a particular week. Okay, that's the time frame in 1 week. Less than 3 accidents occur in a particular week in that week, 1 week. More than 4 accidents occur in 2 weeks. Exactly 6 accidents occur in 2 weeks. Now, you are given the variance is 2.8. So what will be lambda? Lambda will also be 2.8. Okay, now, describe your random variable x. X is number of accident, and x follow the Poisson distribution with mean 2.8. in a time interval of 1 week. So the probability of no accidents occurring in 1 week will be Px equals 0. Substitute into the formula e to the power of negative 2, e to the power of negative 2.8 multiplied by 2.8 to the power of 0 divided by 0 factorial. So you have 0.06081. You round off to 4 significant figure. Part B. You need to find the probability that less than 3 accidents occur in a particular week. So still the lambda is 2.8. So Px less than 3. So we have Px equals 0 plus Px equal 1 plus Px equal 2. Substitute into the formulas. Here I took out the common factor e to the power of negative 2.8. Here your x is 0, your x is 1, your x is 2. Calculate. Okay, you have 0.4695 rounded off to 4 significant figure. C. More than 4 accidents occur in 2 weeks. Okay, will your lambda be 2.8? We have a period of 2 weeks. So your lambda must be multiplied by 2. So hence we have the mean to be 5.6 in a period of 2 weeks. So more than 4 accidents, so Px greater than 4. Again, we have to find 1 minus Px less than equal 4. Okay, substitute Px less than equal 4, which is Px equal 0, Px equal 1, Px equal 2, Px equal 3, Px equal 4. Okay, so you have this. Take out the common factor, which is e to the power of negative 5.6. So x0, x1, x2, x3, x4. Solving, you have 0.6578 rounded off to 4 significant figure. Part D, exactly 6 accidents occur in 2 weeks. So your lambda still remain the same, 5.6 in a period of 2 weeks. So Px equals 6. You substitute x as 6. Your lambda remain the same as negative 5.6. So you have 0.1584 rounded off to 4 significant figure. Question 6. A book has 1,000 pages with 250 printing errors. By assuming that the printing errors occur at random, find the probability that a certain page contains exactly 3 printing errors, more than 2 printing errors, between 1 and 4 printing errors inclusive. So as usual, you have to define your random variable x. So your random variable x is number of printing errors. Now you have to describe the distribution of x. So x follows the Poisson distribution. So how do you find the mean number of errors occurring on one page? I repeat, the mean number of error occurring on one page. So what must you do? Yes, your lambda is obtained by dividing 250 with 1,000. Remember, 1,000 pages has 250 printing errors. So one page has 250 over 1,000 printing error. So your lambda is 0.25 on a page. So after getting your mean for the number of printing errors for one page, then we can find the probability of exactly 3 printing errors on one page. So calculate. You substitute lambda as 0.25, x as 3, and you have 0.0002028. Part B, find the probability that a certain page contains more than 2 printing errors. So this is very straightforward. Okay, with lambda 0.25, so probability of x greater than 2 will be 1 minus px less than equal 2. So px less than equal 2 is px equals 0, px equal 1, px equal 2. Okay, substitute into the formula and take out the common factor e to the power of negative 0.25. So I have here lambda 0.25 to the power of 0 divided by 0 factorial, 0.25 to the power of 1 divided by 1 factorial, 0.25 to the power of 2 divided by 2 factorial. It's easier to calculate when you take out the common factor e to the power of negative 0.25. Okay, calculate. Okay, so you have 0.002161. Part C. Okay, for part C, you need to find the probability that the page contains between 1 and 4 printing errors inclusive. So your lambda remains the same because it still involves one page. So now you need to find the probability of x between 1 and 4 inclusive. So since this is discrete, so we have px equal 1 plus px equal 2 plus px equal 3 plus px equal 4. So substitute into the formula and you take out the common factor, which is e to the power of negative 0.25. So this will be a px equal 1 plus px equal 2 plus px equal 3 plus px equal 4. Okay, you calculate, you simplify, you have 0.2212 rounded off to 4 significant figure. Last example, question 11. A factory manufactures plastic bags and find that 1% of the output is defective. 200 plastic bags are delivered to a trader. Estimate the probability that at least 5 of the plastic bags delivered to the trader are defective. Use a Poisson distribution as a model. So we describe X as number of defective plastic bags. So find the mean number of defective plastic bags. So how do we find the mean? We look at the question again. Okay, the question states that 1% of the output is defective. So we have 1% out of 200 is defective. So your lambda will be 0.01 times 200, which is 2. So your X has a Poisson distribution with mean 2. So now we're going to use the Poisson distribution model. The probability of getting the random variable little x is e to the power of negative 2 times 2 to the power of x divided by x factorial, where x takes the value from 0, 1, 2 onwards. Now you need to find the probability that at least 5. So this is the mathematical symbol for the probability of x greater equal 5. Okay, since x has no limits, so you need to use 1 minus px less equal 4, or you can use 1 minus px less than 5. Okay, so we have 1 minus px equals 0 plus px equal 1 plus px equal 2 plus px equal 3 plus px equal 4. So substitute into the Poisson distribution table. You take out e to the power negative 2 as it is a common factor. So your x is 0 here, 1, your x is 2 here, your x is 3, your x is 4. So calculate. Solving, you have 0.05265 rounded off to 4 significant figure. Okay, that's all class about Poisson distribution. Hope you have understood the lesson. Thank you.